Assalamualaikum and hello everyone. My name is IMAN ATHIRAH binti AZMAN and my student ID is 2024-225232. Today I will be explaining about the meaning of differentiation and the techniques. Differentiation is one of the most important topics in calculus. It is a method used to find derivative of a function. In simple words, differentiation helps us to find the rate of change. For example, it can tell us how fast something is moving or how quickly something is increasing or decreasing. Because of this, differentiation is very useful in subjects like physics, engineering, and economics. To apply differentiation, we use several techniques. The techniques are power rule, product rule, chain rule, quotient rule, multiple constant rule, and sum and differences rule.
Assalamualaikum and hi, my name is LUQMAN and my student ID 2025507811. Question 2. Find dy over dx for the following functions. Here we have two questions, question A and B. Question A, y equal 9e to the power of x tangent x minus 3. If we see this question, we need to use the theorem of product rule, which is dy over dx equal uv prime plus vu prime. Why we need to use this theorem? Because as the functions become more complicated, the product rule will become useful and in many cases required. Firstly, we need to identify this part 9e to the power of x as u and tangent x minus 3 as v. After that, we need to find the differentiation for u and v. So, u is actually 9e to the power of x and v is actually tangent x minus 3. Now, u prime will become 9e to the power of x is unchanged. So, v prime will give you second square x minus 3. How to get second square? You can refer to the formula. So, you have to plug in into the formula dy over dx equal uv prime plus vu prime. That means 9e to the power of x multiply second square x minus 3 and get a 9e to the power of x second square x minus 3 plus vu prime tangent x minus 3 multiply 9e to the power x and we get a 9e to the power x tangent x minus 3. That's the answer for question A. Let's move on to question B. Question B is y equal x squared plus 1 over sine x. As we can see here, we cannot simply do this because we have two terms here, where the first term is actually given by x squared plus 1 and the second will be given by sine x, separated by the division. So what we have to do is using theorem quotient rule. dy over dx equal vu prime minus uv prime over v square. Firstly, we need to identify this part x squared plus 1 as u and sine x as v. After that, we need to find the differentiation for u and v. So u is actually x squared plus 1 and v is sine x. U prime will become 2x because when you differentiate a function, constant disappear. For v prime, we'll get a cos x. Refer to the formula. And then put all value into the formula. It will be vu prime sine x multiply 2x minus uv prime x squared plus 1 multiply cos x over in bracket sine x to the power of 2. We put it back together and we will get 2x sine x minus x squared plus 1 cos x over sine square x. That will be the answer for question B.
Assalamualaikum and hi everyone. So my name is SITI binti Ismail, student ID 2025-742973. Okay, I'm going to present and explain the solution for question 3, which requires us to find dy dx using implicit differentiation. As you can see, the question given, ln y plus sine square x square plus ey equals to 5xy. So there's a few steps you need to do. So the first step, you need to differentiate the functions given. Little did you know, you need to differentiate one by one, such as the first step is ln y and then sine square x square plus ey, and then the last one is 5xy. So you need to do this one by one so that you didn't forget any parts and collect more marks on the question. So the first step I'm going to do is differentiate ln y, and since y is a function of x, we will going to just chain rule. So after we differentiate, it will be look like d divided by dx ln y equals to 1 per y dy dx. So next step is I'm going to differentiate sine square x square plus ey, and since this expression is quite big, we need to use chain rule twice to differentiate this. So the first step is you're going to let u, so u equals to x square plus ey, and then after you differentiate, it will become d divided by dx sine square u equals to 2 sine u cos u dot du dx. You can also simplify 2 sine u cos u to sine 2u, and it will become sine 2u du dx. And now you need to find du dx equals to combine both, and it will become d divided by dx x square plus d divided by dx ey, and it will become 2x plus ey dy dx. So after you combine everything, it will become sine 2x square plus ey 2x plus ey dy dx. Step 3, you need to differentiate 5xy, and for this one we are going to use product rule, and it will become d divided by dx 5xy equals to 5x dy dx plus 5y. The next step is collect all differentiate you did earlier and make it a complete set of differentiate equation. So after we combine, we getting 1 divided by y dy dx plus sine 2x square plus ey 2x plus ey dy dx equals to 5x dy dx plus 5y. And now you need to expand the second term, and it will become 1 divided by y divided dx plus 2x sine 2x squared plus ey sine 2x squared plus ey divided dx equals to 5x divided dx plus 5y. And now you need to collect all the dy divided by dx terms on the left, and it will become 1 divided by y plus ey sine 2x squared plus ey minus 5x dy dx equals to 5y minus 2x sine 2x squared plus ey. So the next step is you need to solve for dy dx. So you need to divide both sides to isolate dy dx, and it will become 5y minus 2x sine 2x squared plus ey divided by 1 per y plus ey sine 2x squared plus ey minus 5x. Little did you know, you can also remove y from 1 per y, the previous step, by multiplying it with y. So after you multiply with y, it will become dy dx equals to 5y squared minus 2xy sine 2x squared plus ey divided by 1 plus ey sine 2x squared plus ey minus 5xy. So this is the end answer. So that's it. That's all for question 3. And thank you.
Assalamualaikum, my name is ZUHAIRA binti ZULKIFLI and my student ID is 2024653166. Today I'm going to explain how to answer linear approximation questions. So based on the question given, use linear approximation to estimate the value of 8.02 square minus 3 third 8.02 correct to 2 decimal places. Then let's see the equation for linear approximation. Fx naught plus delta x equal to fx naught plus f prime x naught delta x, where delta x equal to x minus x naught, x equal to given value and also x naught equal to the chosen value. Let's solve the question. First, we let function equal to x square minus 3 third x equals to x square minus x the power of 1 over 3. The x value is equal to 8.02 while x naught is equal to 8. Then we find the delta x value, which is x minus x naught equals to 0.02. Then substitute x equal to 8 into function, which is 8 naught minus 3 third 8, and then we got 64 minus 2 equal to 62. After that, let's find f prime. F prime equals to 2x minus 1 over 3x, the power of negative 2 over 3, which is equal to 2x minus 1 over 3 third x squared. Then substitute x equals to 8 into the f prime, which is 2 multiplied by 8 minus 1 over 3 third 8 squared equals to 16 minus 1 over 12. Also the same value as 191 over 12 also equals to 15.92. Lastly, substitute the obtained value into the equation. F 8.02 equals to 62 plus 15.92 multiplied by 0.02, which is equal to 62.3184. Since the question asks for 2 decimal places, thus the answer is 62.32. That's all from me, thank you.
In completing this assessment, several important concepts in differentiation have been applied, including the basic meaning of differentiation, techniques of differentiation, implicit differentiation, and linear approximation. Based on the solution and analysis, I would like to present the following recommendations. First, strengthen understanding of basic techniques of differentiation. From question 1, it's clear that differentiation includes several techniques like the power rule, product rule, quotient rule, chain rule, and implicit differentiation. I suggest students practice each technique individually and then learn how to combine them. Many functions, especially in questions 2 and 3, need multiply techniques at once. Second, practice recognizing patterns before differentiation. In question 2, finding the derivatives required identifying the right technique. First question, exponential plus trigonometric function. Second question, quotient of function involving sign. I recommend identifying the inner function, outer function, and overall structure of the equation before starting to differentiate. This approach helps reduce mistakes and improves accuracy. Third, improve skill in implicit differentiation. Question 3 shows that many real functions cannot be rearranged to express y explicitly. Implicit differentiation becomes essential. I suggest students regularly practice differentiating equations where x and y are mixed together. This technique is used often in physics, engineering, and economics. And the last one, apply linear approximately for fast estimation. In question 4, linear approximation estimates complicated function values. I recommend using linear approximation as a quick and efficient tool, especially when calculators are not allowed or when checking if answer makes sense. This technique is very helpful in real-life situations such as error estimation and small change in measurement. In conclusion, mastering differentiation requires not only memorizing formulas but also understanding when and how to apply them. With continuous practice and a strong foundation in the core techniques, students will be well prepared for more advanced calculus topics and practical application in their academic journey.